11.4, area of regular polygons and composite figures. First, we're going to start with regular polygons. And in order to find the area of a regular polygon, we need to know the apothem. And the apothem is the distance from the center of the regular polygon, point A, to the opposite side that forms a perpendicular line, right? So it's 90 degrees. So AP's length is the apothem. Right? And then we need to understand also that a regular polygon has same side measures and angle measures. So same side and angle measures. Okay, so if that's the case, then the area can be calculated by plugging into this formula, which is 1/2 times the length of the apothem times the perimeter of the polygon. So the first example is to verify the formula. A is equal to 1/2 AP. And how can we do that? Well, what we can do, one of the ways to show that the formula is valid, is we can get the area of the triangle ARP. And if we get the area of triangle ARP, then we can go ahead and multiply it, because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 such triangles. And so we could just multiply that area by 10. Right? Okay. We don't know the apothem, the length of AP, so we're going to use the value A, or the variable A. And we don't know RP either, but we know the perimeter is P, right? And so if the perimeter is P, then that means RP is P divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we can say that RP, let me go ahead and write this down. RP is equal to perimeter divided by 10. All right. And then the area of ARP is equal to 1/2 base times height. So 1/2 of the base is here, RP. So it's going to be P over 10, perimeter divided by 10, times the height, which is A. So we'll go ahead and work that out. Oh, did I do something wrong? Oh, right. So wait, 1/2 base times, oh, right. So that's the area of triangle ARP. So let's go work that out. That's going to be P over 20 times A. So it's going to be PA over 20. And so we need to take the area of ARP and multiply that by 10, because there are 10 such triangles in this regular polygon. So the area of the polygon is equal to PA over 20 times 10. And that will simplify to 10 PA over 20, and that simplifies to 1/2 A times P. Right. So we've shown that to be the case, which is great. And now we have example number 2, which is a standard problem, right? They give us the perimeter, we need to find the area of the regular polygon. And this is a little bit tricky. So what we need to do, or one of the ways that we can figure that out, is we don't know the apothem. Right? So we need to figure out what the apothem's length is if the perimeter is 60. And it is this pentagon up here in the figure. So how can we do that? Well, we know that the number of degrees in an entire circle is 360. Right? So then that means that this central angle RAS is equal to 360 divided by 5. Right? So because there's 5 such angles that make up the polygon. So let me go ahead and say this. Measure angle RAS is equal to 360 divided by 5. So then that's going to equal to 72 degrees. Right? So that's central angle RAS. But we don't want central angle RAS. We want the angle RAP. So that means that the measure of angle RAP is equal to 72 divided by 2, which is 36 degrees. Okay, so angle RAP is 36 degrees, and we know the perimeter is 60 centimeters. So we know RP, right? Because RP is equal to 60, the entire perimeter, divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, divided by 10. So I'm going to go ahead and say RP is equal to 60 divided by 10, so that's equal to 6. Okay, and so now what do we have? Well, let me go ahead and draw the triangle ARP over here. This is my A, my R, and my P. I'm looking for lowercase a, the apothem side, right? And in this triangle, we know RP is 6, and we know that ARP is 36 degrees. So to find A, we want to go back to our trigonometric ratios, right? So if this is our angle that we're dealing with, then we have opposite and adjacent. And if you remember SOHCAHTOA, right? Which of the trigonometric ratios will help us find A? Well, we have opposite and we have adjacent. Opposite and adjacent is tangent, right? So it's going to be, the equation is going to be tangent of 36 is equal to opposite 6 over adjacent A. We could multiply both sides by A, and we'll get A tangent 36 is equal to 6. And then we divide by tangent 36. So we get A is equal to 6 over tangent 36. And then we'll drop that in calculator. So give me a second here. Let's do calculator. Oh my goodness. Calculator. And then I could put in these values. So 6 divided by tangent 36. Make sure I'm in degrees mode. Hit equals. And it is... Oh, that doesn't look right. This is degrees mode. So let me go ahead and do this again. So if the degrees is not shaded, then that means it's in degrees mode, right? If the degrees is shaded, it's not in degrees mode, it's in radian mode. So I'm going to do 6 divided by tangent 36. There we go. So that's going to equal to, what is this? 8.26 is the apothem. And now that I have the apothem, finally, I can go ahead and plug in because I know my perimeter is 60. I know my apothem is 8.26, so I can find the area. So area is equal to 1/2 apothem, 8.26, times the perimeter, 60. And I'm going to drop that all in a calculator. And I'll get 0.5 times 8.26 times 60 is equal to 247.8. And remember, when we're dealing with area, we do need to put the units down, which is centimeters, and units are always in units squared, right, when we're dealing with area. So that is our final answer. Yeah, so quite a bit of work, leveraging some of the knowledge that we learned in past chapters. So we're going to need to practice this quite a bit before we get it down.